Physics Part 55. For the particular case of a particle projected with velocity u at an angle to the horizontal from a point on level ground, the range r is defined as the distance from the point of projection to the point at which particle reaches ground again. Well, because of the downward acceleration of g, the y component of velocity decreases to 0, at which time the particle is at the crest of its path, and then increases in the magnitude again, but this time in the opposite direction. And then increases the magnitude again, this time in the opposite direction. The path is again a parabola. We can show that r is given by r is equal to u square sine 2 theta divided by g. For details, see maths notes. The maths notes, as explained, suppose that the particle is projected from the origin x is equal to 0, y is equal to 0. We can interpret the range of r as being the horizontal distance x traveled at the time t when the value of y is again 0. The equation which links displacement, initial speed, acceleration and time is s is equal to ut plus half at square. Adapting this for the vertical component of the motion, we have 0 is equal to u sine theta t minus half gt square. The two solutions of these equations are t is equal to 0 and t is equal to 2u sine theta over g. The t is equal to 0 case is when the particle was projected. The second is when it returns to the ground at y is equal to 0. We use this second value of t with the horizontal component of velocity u cos theta to find the distance x traveled, the range of r. This is x is equal to r is equal to u cos theta, t is equal to 2u square sine theta cos theta over g. There is a trigonometric relation in sine 2 theta which is equal to 2 sine theta cos theta, use of which puts the range expression in the required form. R is equal to u2 sine theta over g. We can see that r will have its maximum value for a given speed of projection u when sine 2 theta is equal to 1, or 2 theta is equal to 90 degree, or theta is equal to 45 degree. The value of this maximum range is r max, u square over g. Examples. A stone is thrown from the top of a vertical cliff 45 meters high above the level ground with an initial velocity of 15 meters per second in a horizontal direction. How long does it take to reach the ground? How far from the base of the cliff it is when it reaches the ground? To find the time t for which the stone is in the air, work with the vertical component of the motion, for which we know that the initial component of the velocity is 0, the displacement y is 45 meters, and the acceleration of a is 9.81 meters per second. The equation linking there is y is equal to half gt square. Substituting the values, we have 45, which is equal to half into 9.8 t square, 9.81 t square. This gives t is equal to under root 2 into 45 into 9.81, which is equal to 3.0 seconds. For the second part of the question, we need to find the horizontal distance x traveled in the time t, because the horizontal component of the motion is not accelerating. X is given simply by x u x t. Substituting the values, we have x is equal to 15 into 3.0 is equal to 45 minutes. I beg your pardon, 45 meters. I beg your pardon, please.